I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very special question from the past test papers of IITJEE. Now in this series, we are going to solve many questions based on past test papers. This is a very special series for me as I am collaborating with my friend in France, Mr. Narad. So Mr. Narad will be providing me with some solutions to questions and strategies. And I hope these strategies will help all our viewers and subscribers to understand the topic better and perform very well in their own exams. So the question here is, suppose alpha, beta are roots of x squared plus kx plus 1 equals to 0, and gamma, delta are roots of x squared plus x plus k equals to 0. Part A of the question is, if alpha, beta, gamma, delta are in arithmetic sequence, then find the common difference of these arithmetic sequences in terms of k. Part B is, if alpha, beta, gamma, delta are in geometric sequence, then find the common ratio of this geometric sequence in terms of k. So I hope the question is absolutely clear. We'll try to understand the strategy behind the concepts which can be applied effectively to get the solution, right? So first thing is part A. Let's look into that part, where we are saying that alpha, beta, gamma and delta are in arithmetic sequence. We need to really find the common difference, right? So if these are in arithmetic sequence, then you could write alpha as one term, right? It could be the first term. But beta will be what? Well, beta will be alpha plus delta. Let's say D, the common difference, right? And gamma will be alpha plus 2 times the common difference, and delta will be alpha plus 3 times the common difference. That is what it means, right? So we need to really find the common difference of this arithmetic series, and this common difference, I'm taking that as D. So that is what your first question is, right? Part B basically is that these are in geometric sequence. So if alpha, beta, gamma, delta are in geometric sequence, in that case, alpha is one term, then beta will be equal to what? Beta will be, let's say, the ratio is q. So beta will be alpha times q, right? And gamma will be alpha times q squared. And delta will be alpha times q cube. So that is what is given to you. So when we say this, right? Now, I'd like you to pause the video and answer the question. Perfect? Simple as that.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student, Akshit, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So we have got some concept here. Now, how do we relate these alpha beta with the quadratic equations given to us? That is the second component of concepts. So let's look into this. So let's get into details of question number 1, which says alpha, beta, gamma, delta are the roots of these given equations, right? Since these are quadratic equations, how are the roots related with the quadratic equation? This is what you need to answer, right? So let me give you an idea. If alpha and beta are the roots of the given quadratic equation, then we can always say that x minus alpha times x minus beta will be equal to 0, right? Since they are roots, right? So when you open this up, what do you get? You get x squared minus beta times x. When you multiply with alpha, you get minus alpha times x plus alpha beta, right? Equals to 0. And here you can take minus common with x common, right? What do you get? You get alpha plus beta or beta plus alpha in the brackets. So let me rearrange and write them as alpha plus beta times x plus alpha beta equals to 0. You get the idea. So this is commonly known to most students. However, I thought it important to derive here. So what you notice here is that the coefficient of x is sum of roots with negative sign, right? So we can relate that to the equation. Perfect. So we can write that alpha plus beta is equal to what? In this case, plus k, right? And negative of this. So we can write this as minus k. And also, we can say that the product of root is 1. Alpha times beta is equal to 1. Makes sense? Do you see that part? So, alpha plus beta is minus k, and alpha times beta is plus 1. Now, same strategy if we use for the second equation, which is x squared plus x plus k equals to 0. In that case, from the second equation, the sum of the roots, which are gamma and delta, should be equal to what? Minus 1, right? So we have gamma plus delta equals to minus 1. And the product of roots, which is gamma times delta, should be equal to the constant k. Perfect. So that is how we get two sets of equations. And now, using these equations, we can solve part A and B, right? So let's look into their solutions now. So let's have a good look at part A, where we are given again the equations x squared plus kx plus 1 equals to 0. The sum of roots alpha plus beta is equal to minus k. The other equation is given to us as x squared plus x plus k equals to 0, and the roots gamma plus delta will be equal to minus 1. Product of gamma and delta is equal to constant k. Now, since we will do part A, which is we are given they are in arithmetic progression, right? It really means what? Arithmetic progression of roots alpha, beta, gamma, delta, as discussed earlier. The roots will be alpha, alpha plus d, right? And then gamma will be alpha plus 2d, and delta will be alpha plus 3d, correct? Now, when I say alpha plus beta is minus k, it means what? It means alpha plus d is minus k, right? So we can rewrite this equation as alpha plus common difference is equal to minus k. And now for gamma plus delta, gamma and delta will be 2 alpha plus 5d, right? So this equation will give us what? It will give us 2 alpha plus 5d, 2d plus 3d, 5d is equal to minus 1. You get the idea. So one equation is 2 alpha plus d equals to minus k. The other one is 2 alpha plus 5d is minus 1. Let's call them as equation 1 and equation 2. Clear? Now we can eliminate alpha by subtracting one equation from the other. So if I do equation 2 minus equation 1, what do I get? 5d minus d is 4d, right? And here we have minus 1, minus of minus k will make it plus k, right? So that gives you the value of d, the common difference, as minus 1 plus k divided by 4. Is that clear to you? So that becomes solution of part A. So we have found the common difference d when alpha, beta, gamma, delta are in arithmetic progression, correct? Now let's do part B. In part B, we are going to use the product of the roots, right? And we'll see how is the ratio related. So once again, let's do part B now. Equations given to us, x squared plus kx plus 1 equals to 0. If alpha and beta are the roots, then their product alpha times beta will be 1, right? That will be our equation number 1. Second equation, x squared plus x plus k equals to 0. So in this case, the product of the roots, they are gamma and delta, right? So gamma times delta is equal to the constant k, right? That becomes our second equation. Now, since these equations are in geometric progression, it means what? It means the roots alpha, beta, gamma and delta should be, if one is alpha, the other one will be alpha times q, right? If q is a ratio. And then will be alpha times q square and delta will be alpha times q cube. Make sense? So we have written, you see how we have written? Alpha, beta will be alpha times q, gamma will be alpha times q square, delta will be alpha times q cube. So here are all these equations in terms of q, right? So easily we can write what equation 1 will be. So alpha times beta means what? So if I multiply alpha times beta, then I get 1, right? So let's rewrite this. Alpha times beta 1 means alpha times q, right? Alpha times beta equals to 1 means alpha times q equals to 1, or alpha square q equals to 1, correct? On the other hand, gamma times delta is k, right? Now, what is gamma and delta? Alpha times q square and alpha times q to the power of 3, right? So it becomes alpha times q square times alpha times q cube equals to k, or alpha square q to the power of 5 equals to k, right? So that gives us equation number 3 and 4, right? Now easily, we know alpha square q is 1. We can divide one by the other. So let's do the quotient of equation 4 and 3. So we get what? Let's rewrite. So we get alpha square q to the power of 5 divided by alpha square q is equal to k over 1, right? And that is q to the power of 4 is equal to k, and q is 4th root of k. So in terms of k, we have our answer. Quotient being 4th root of k, correct? So I hope the solutions are absolutely clear. In case you want to learn directly from me, you can always send an email on the address given. Here is a complete solution in short. So we're working with these two equations, right? Given the roots alpha and beta, so the sum will be minus k and product will be 1, right? For the other root, gamma delta are the roots of the other equation. Their sum will be minus 1 and product will be k. Working with these, when we are working with arithmetic progression, common difference being d, the sum of roots can be written as 2 alpha plus d, common difference, and the other one 2 alpha plus 5d. And solving these equations, we get d as minus 1 plus k over 4. For geometric progression, we have taken the product of roots. For alpha and beta, it is 1, and for gamma and delta, it is k, writing them in terms of alpha and q, where q is the common ratio between the roots. We get the value of q as 4th root of k. Clear? So with this, we end our video, and I hope you understand complete concept of solving such questions. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.